Hello, everyone. On behalf of IBM Systems Magazine, I'd like to welcome you to our presentation. My name is Janine Donnelly. I am the manager of webinars for IBM Systems Magazine, and I will be the moderator for today's event. We will be holding a Q&A session at the end of the webinar. You may ask a question at any time during the event by entering it into the Q&A panel. If you experience technical difficulties during the webinar, please use the Q&A panel to alert us, and someone will assist you. You may download a PDF version of the slide deck by clicking on the drop-down menu labeled Event Resources on the left side of your screen. Also in Event Resources, you'll find additional documents related to what we'll be talking about today, so be sure to check those out. Again, those are downloadable. Today's webinar, Pen Testing to Reveal the Truth About Mainframe Security, is sponsored by CorreLog, Inc. Our featured speakers today are Philip Young and Peter Mills. Phil was previously a mainframe security researcher at a large financial institution. In his current role, he performs mainframe penetration tests, teaches mainframe penetration testing classes, and speaks at conferences like DEF CON to raise awareness about mainframe security. Peter Mills is the Vice President of Development and Support at CorreLog. He has more than 37 years of experience in information technology, having previously served as software engineer, systems architect, business analyst, project manager, and development manager on both IBM mainframe and Windows PC platforms. And to get things started today, I'd like to now turn it over to George Foucher, President and CEO of CorreLog. George?
Thank you, Janine. Good afternoon, welcome, and thank you for attending our pen testing and remediation demo. CorreLog is one of the leaders in mainframe security monitoring for some of the largest mainframe data centers in the world. We have some pretty exciting breach attempt detection technology to show you today. As you can see, Ponemon Institute determined the average time to detect a breach is 191 days, or 6.5 months. Also, the average time to contain a breach was 58 days. Wow. This means that the hacker has their way with your data. We'll be featuring ZDefender, DB Defender products here today and show you how to protect the mainframe in real time, as well as integrate with your Security Operations Center and SIM products for correlating events, alerting, and opening problem tickets. We're certified partners with IBM, QRadar, HP ArcSight, RSA, McAfee, and also work with Splunk, LogRhythm, NetIQ, and more. So regardless of what you've got out there in the Security Operations Center, we can integrate with it. We have lots of good things to show you today, so I'll cut this short and begin the demo in just a second. I want to thank Phil Young for joining us today. You probably heard him speak at some of the conferences, IBM Share, RSA, and so on. He'll point out some of the mainframe vulnerabilities, and Peter will show you how we detect and alert on them in real time. Feel free to post questions into the window. Stop by our booth at the Share conference if you're attending, or contact us to get a live demo in your own environment or via WebEx. Thanks again, and I will pass it on to Phil. Phil?
All right. Thanks, George. Before I get started, I've been told I have to put this in front of every one of my talks. So just so we're clear, I'm not here in the name of or representing my employer. Everything I represent here is my own opinion and stuff that I've sort of done on my own time. So a little bit about me. I was a kind of a hacker kid in the 90s. If anyone remembers what a BBS was, I'll show you an example of that in a second. But basically, in my early teens, I was exposed to systems like this, which is basically a BBS, right? So you log in, you connect with a modem, and you browse around, you look for files. initially when I was connecting to BBSs, it wasn't anything too interesting until I got access to like a hacker freaker BBS. This is what a BBS looks like. Eventually it led to access to files like this. So this is from 1987, right? So a while ago. This is how to connect and how to go after or connect to companies and corporations that are connected to Telenet. If Telenet doesn't mean anything, think SprintNet, TimeNet, stuff like that. So when you're connected to those networks, you have to go through various routes. I was doing all this through Canada, so I actually came across this first, which was a guide to going after and connecting to things through DataPack, which was a Canadian X25 network. So in my teens, instead of doing regular things, I was on a 486 computer that I bought with my own money in my room, trying to connect to interesting sites. So we're going to skip way ahead. We're going to skip about 10 years into the future. That led eventually to me being and working in Big Four consulting, where I was the penultimate checklist auditor. I would literally, they'd say, you're going here. You have experience with Unix and Linux, so we're going to send you to major Canadian bank, and you're going to audit their entire sysplex and like 12 LPARs. I have no idea what I'm doing. Oh, here's a checklist with some questions to ask. Okay, terrible. I was a mainframe security specialist. That's how they were farming me out. Huge asterisk there because obviously coming into the scene, I knew nothing about mainframe security going into that job. Eventually that led into a full-time position within Visa's internal audit department, where what really sort of kicked off this deep dive into mainframe hacking, mainframe penetration testing, where we were on a mainframe engagement and we had brought in a company to help us do the pen test, and they knew less about mainframe pen testing and security than we did, though they were billed as a mainframe security expert. So that really kind of made me nervous for the platform long term because, as people start to retire off, there's a lot of tribal knowledge leaving, and there may be stuff that's not fixed, and it's not in the auditor checklist, right? So that led me down this rabbit hole of mainframe pen testing. The other thing is there's terrible community support in terms of outside of the mainframe community. If I go to hacker conventions, I go to security conventions, I go to audit conventions, you talk about, hey, how come you're not talking about this platform? Oh, do people still use it, right? And hackers and mainframers don't talk. I think that's probably a byproduct of the 90s where people were told that hackers are evil, and so therefore don't talk to them, they'll go after your system. And that's not the case really anymore. Companies hire penetration testers, which is just another word for a hacker, to come in and actually test their security before a real hacker tries to do it. So I was really interested in the platform, and I was somehow able to obtain a copy of ZOS, and I was able to run it on an old laptop, and it was really slow. I think it took, I remember the first time I ran it, it took about 45 minutes to IPL and there's nothing on it. There's nothing running on it, just to IPL the system. So, mind you, it took an entire weekend to get to the point where I could IPL, but that's a different story. It was very slow, but it was enough for me to start doing initial research on it. And that's when I started to realize, like, well, there's stuff in here that's not on the checklist. And there's stuff on the checklist that are, technically correct, but the risk ranking and all that information is not actually describing the actual problem state. So I started working with that and started creating tools and libraries, which we're going to see in a minute, on how to go after the platform. I started adding, me and a couple of other people, started adding support for tools to allow people who do pen testing to do good pen tests on the mainframe. So Metasploit is a platform, the framework to help you do penetration tests. So we added, and in fact, specifically Chad added support for ZOS within that framework, which is all open source, by the way. John the Ripper, so Nigel Pentland worked to add support for John the Ripper after I was trying to do it by myself, and I reached out to him for help. Nmap, so I wrote Nmap libraries to add TN3270 to support the platform, to support the product. That's an open source port scanner, which you'll see in a minute. And then Python whole bunch of libraries for Python, for tools to help doing pen tests, and a bunch of rec scripts to help once you've connected to the system or once you're on the system, what can you do? And Rex is really powerful and lets you do a bunch. I've given a bunch of talks on this topic. If my demo is here sort of piquing interest and you want to see some more, you can go to that YouTube link. It's a playlist of all my recorded talks from various conferences like B-Side, DEF CON, Black Hat. I've spoken at ISACA. I've spoken a whole bunch of places about the platform. And if you don't remember, I gave a keynote at Share maybe 2 years ago, and here's me wrestling with a water bottle for a good 2-3 minutes while I'm up on stage giving a keynote in front of 2,000 people. So being a presenter is not all fun and games. On top of this, I also run what I call the Mainframe Internet Project, which is available at mainframesproject.tumblr.com. And what that is it's a bot. I mean, it's a bunch of scripts I wrote, but it's a bot that goes out and it searches the internet for mainframes that are connected, that are publicly accessible, and just takes a screenshot, right? I think it's interesting to see what's out there. It's interesting to see what people are running, and it's also interesting to see some of the artwork and that kind of information. It's also just an information point for me to feed into other scripts. So for example, so we'll load up this one. So this is an interesting one for me, not so much for the company. I don't know who this company is, but specifically it tells me where the USS table was kept, right? So I don't have to, this is just given to me for free, and also tells me the operating system version, right? Also tells me the terminal name, so maybe I could do some LU stuff. I could start brute forcing LUs. This one's interesting just because it's a nice picture with ZOS on it. This one really doesn't give you much. It might give you the LU here, but it gives you the LPAR name, so that's enough for me to probably figure out what's going on. And then this is probably one of my favorites. This is from a university, and it tells you specifically all the applications that are on here so I can just type in any of these applications and see where it goes. And does it require a login? Does it not require a login? Is there a form for me to upload stuff? Does it go to Kix? If it goes to Kix, can I go after, say, CECI, CEDA? So there's a whole bunch of avenues that this opens up. But if this screen isn't here, that doesn't mean I can't go after the mainframe, and you'll see that in a minute. There's also others in this space that are worth following. So you have Chad Rickenstrud, so he wrote the Metasploit stuff. He also wrote the first ZOS buffer overflow. If you look at the talks, there's a DEF CON talk with him in it, where he talks about how he did it and how possible and feasible it is. He's also written some ZOS malware as a proof of concept. Gave a great talk at Share about how that works and how he would go about it, and everyone left the room really sad. He's improved John the Ripper. He's really an all-around awesome mainframe hacker. Ayub El-Assal, he wrote Kixpwn, and he's also written some of the privilege escalation scripts I'm going to demo for you in a few minutes. And he's also added some support to an enumeration script that I wrote. Really cool guy, really young, very interesting to see the work that he's doing. And there's a few others in this space. We joke that in the mainframe hacker community, when there's 3 of us in a meetup, 50% of the community is in attendance, right? It's very small. I would say there's maybe, and over time it's grown from 3 to 4 to maybe 8, 9 people. But if you have a chance, so Jay Taylor, he's on GitHub, but he's written some additions for enumeration script. He figured out that you could find all this setter ops listing within storage and wrote a rec script to do that, and then I incorporated that into enumeration. Henry Kipper wrote sudo for the mainframe, so it allows you to do some kind of like run privilege escalated commands without giving someone privilege escalation. Also brings me ideas on what to look at. And then Dominic White wrote the Big Iron Reconnaissance and Pwnage platform, which allows you to go after TN3270 applications. So with that sort of out of the way, we're going to walk you through now what a mainframe penetration test would look like. Before I go too far into a mainframe penetration test, I want to sort of talk about some of the terminology. So we're going to talk about reconnaissance, right? So that's the act of looking for things. Port scan. We use what's called a half-open port scan. So that is, if you know TCP IP, if you know TCP specifically, you know it sends SYN, ACK, SYN, ACK, right? So that's your 3-way handshake, really. we use a half-open connection. So we send a SYN, and we wait for an ACK, and then we don't connect again. So we don't send anything back. But if the machine has sent an ACK back to us, that means the port is open. Nmap is specifically the tool that does this type of scanning. You can do full connections, all kinds of stuff you can do with Nmap. Nmap just stands for Network Mapper. It was a tool released in the 90s when sort of the internet and stuff was coming up. Brute force means I'm literally just, I'm going as brutally as possible trying to guess a password. I'm just going to try everything. And it's a brute force because it's noisy and it's gross. Privilege escalation, that means I'm going from a level of access which has very little access to stuff, and I'm going to escalate that through means available to me to get access to things that I didn't have access to before. So I'm on a system, and specifically within pen test, that's kind of the goal when you connect to a system. You're trying to escalate your privileges to get access to more stuff. So that's one of the things that we do on a pen test is privilege escalation, and then security incident event monitor is something you'll see at the end. That's what sort of correlates everything and allows you to see what's happening during these attacks. So these are the general steps to a pen test, right? There's this is a pen test. If it was a real bad actor out there going after your environment, there'd be a step 6 here which says steal your data. But that's not my job as a pen tester. My job is to find the weaknesses and then exploit them and get into the system. Sometimes clients may want a red team engagement, which is literally go in like a hacker and steal the data, see what you can get to. But for the purpose of the demonstration, I'm just going to stop at once we get privilege escalation. But the steps are reconnaissance, enumeration, access, then do internal enumeration once we're on the system, and then privilege escalation. Reconnaissance is probably my favorite thing to do, only because it's easy and it involves finding out cool things. It's like a puzzle. Really, all you're doing during the reconnaissance phase is searching SharePoints, searching internal documentation storages, searching, say you have a repository where you keep all your attachment configuration files so that people can just download them to their machine and use them. That contains, that's just an ini file, which contains all the information you need to connect to a bunch of LPARs. That's great. That's information I wouldn't have normally. Also, here's how we connect to this application. Well, that's probably going to have user IDs in it, example user IDs that people use. Or I might find forms that people fill out to get access to the mainframe that says, okay, when you're done with this form, you will get an ID that starts with the letters, BOA, and then number. Well, great. Now I know every single ID on the system is going to be BOA, number. I'm going to search for other kind of stuff, and then I'll do an Nmap scan just so that I can see what's running on the box. So this is where the demo is sort of supposed to begin, so let me see if I can get that working. But basically what we're going to do is we're going to do some scanning, see what's on there. Can we use what's on there to get more information about the platform, and can we exploit anything on that platform to further our access? So let me go into and share my screen. Right, so Nmap, real quick, we can tell these ports don't really look open. I mean, they're open, but they don't really look like it's a mainframe running them or anything like that. Maybe if we do what's called a banner scan, which is -SV, we'll get more information. So specifically what I care about here now is it's told me that, well, one, it's told me the version of the operating system, so that's good to know. But it's also told me, okay, so it's running TN3270 on these 2 ports, which is interesting because, usually you might see it on 1 port, but I don't know why it's running on 2 ports. So we use a script called TN3270 screen to look at those 2 port specifics. I'm going to pass it 2 ports, 23, 23, and 23, and we'll see what's running on those 2 screens. So on the first screen, looks like a normal TN3270 connection screen. The second one looks like a login straight into TSO. So that's kind of strange. So we'll keep that knowledge in the back burner. We know that we can connect straight into TSO. Now what we're going to do is we're going to connect to Smug through a normal TN. So we've confirmed now, okay, this is just normal, regular TN. But I don't know what this is, right? This could be some weird TPX thing. It could be, What I'm hoping is that it's VTAM. So I'm going to type IBM test to figure out what's running on the port. Okay, so sure enough, it's running VTAM. Now what I can do from here now is I can do, log on Apple ID fake and see if that exists, right? Oh, it definitely doesn't exist. I could do that by hand forever, but I'm not going to do that. So we're going to do mmap smog. We're going to pass it to port 23. I'm going to pass it a script that I wrote called vtam enum. I'm going to pass that an argument called ID list equals vtam.text. So this is a list of things I picked up from documents or names of applications that might exist, TSO, A06 TSO, stuff like that. And then we're going to run it. I'm going to slow it down a little because we are on a demo system. Let's slow it down a little. And then I'm going to turn up verbosity so we can see what's going on. So we're going to run this, and here you can see what it's doing is it's connecting and trying to guess valid application IDs that exist on the system. Very fast, and that was with me limiting how many connections it does at once. By default, it does about 25 connections. So, okay, great. So we're here. So we can see TSO is running, A06 TSO is running, and Kix TS52 is running. Great, perfect. I know that they're running TSO because we saw that on the other screen. And I also know through doing some research based on, looking at various documentation that every account on the system starts info S and then number. So every single account is going to start with info S, number, other than some administrative accounts that I have. And we have a file that I created before the demo called tso.text, which contains guesses at what may exist on the system. I also saw fake user IDs, so I just put those in to see what that looks like. So we're going to use that now. We're going to connect to smog. We're going to go to port 23 again. Let's see if I can. We're going to pass it the script TSO enum. We're going to do the same thing, script args. This time we're going to pass it a user file, which is the one you just saw, tso.text. And then we're also going to slow it down because this, when run at full speed, it has broken the system. I can tell for a fact, though, using in production, I can enumerate an entire environment in about 30 minutes, 45 minutes. And then we'll just turn up verbosity here. So what the script does is it connects, sees if it can get to TSO. If it can get to TSO, then it starts trying user IDs to see if they work. And then if the system is slow in responding, it'll keep trying a user ID for about 10 tries until the system gets back. That's why you see these repeats here for like info S6 and stuff like that. So it's running, it's trying various user IDs to see if they exist on the system. And all it's doing really is on that TSO login panel, it'll tell you, oh, you fat-fingered your user ID. That user doesn't exist on the system. Well, it's using that to its advantage to tell, is this an actual user ID or not? So here we can see in the output here in the log, you can see things like fake 6, not a valid user ID, but valid TSO info S9. And so here we have a list now of valid users. We also saw previously that FTP was running, and we'll talk about why that's important in a second. But so now we have this information, right? So we know they're running TSO. We have a list of valid users. We also know that they're running FTP. And there's a whole bunch of tools that allow you to do brute forcing. And I know, just from reading documentation, that the help desk always sets accounts to the password demo. That's just what they do. Whenever they set up a new account, they use the password demo. Obviously, that's for this demo specifically, but I just know that from doing research, and I've seen this happen in the wild. So I have a file here called pass that contains the word demo. I'm going to use a tool called Hydra. So Hydra does real rapid brute forcing against a service. And I'm going to use it. So I've taken all these user IDs, info S1 through 20, and I've put them in a text file called validusers.text. I take that password, which is just demo. I load that up as well. V is just to to make it so it's visible so you guys can see what's going on. I'm going to give it 5 threads to go after the FTP port. That's the important bit here. So I'm going after FTP on Smog, and I'm going to pass it these accounts. So it's going to try a whole bunch. And you can see here real quick, didn't take very long, now we have a valid user ID through FTP, right? And we know that that user has access to TSO. However, maybe there are other people who don't have access to FTP that have access to TSO. So what we can do is we can use another Nmap script called TSO brute to do the exact same thing, but we're going to do this against TSO. So we pass it user DB equals valid underscore users dot text. So that's the same thing we passed it, right? So it's InfoS 1 through 20. And then we pass it the pass DB is equal to pass.text. Same thing, demo, just one word. Why do we do it this way? We do it this way specifically because most companies have account lockout thresholds of 3, 5, somewhere in that range. But I'm not testing 5 passwords or 10 passwords against one user. I'm trying one password against all users. And 9 times out of 10, that A doesn't go detected, and B will yield anywhere from 0.01 to 0.001%, depending on how large of a user base I get. Now, the important thing here to know as well is this script will try to put the user as the password first, and so that will up the count of the account lockout threshold. So we set that to false here. That's what this brute.user_as_pass does. Otherwise, every single time it'll connect twice, which I don't want to do. It's going to run this. You know what? Let's turn up verbosity so you guys can see what's actually happening in the background. So we're going to connect, and now it's just going to try username and passwords. It's trying the same things that the FTP one did, but it's just going to try valid username and passwords. And there we go. So we have a valid password found, InfoS 10, demo. So, okay, so we have a valid user on the system, and this can run while it's finishing up. But now that we have a valid account, so look, I only needed one, right? I only got one valid account on the system. If I was feeling adventurous, I might try 2 passwords in a day. So I'd run this once with, say I have 10,000 user accounts to try, right? So I have 10,000 valid user accounts. I can try maybe all of them with 1 password, and then try that again later that day, and then just wait the afternoon, right? Or if I'm really paranoid, I could wait until the next maintenance cycle, you re-ITL the system, and then I could try again, right? Basically, I'm trying to avoid locking people out of their accounts, otherwise, because then they call me and say, what's going on? Okay, so we have a valid account here, demo. Let's log into the system and see what that user account has access to. So I'm going to go into TSO, InfoS 10. The password is demo. Okay, so we're ready at the prompt here. Let me real quick FTP up as well. Okay, so let me delete some files here real quick. I need to upload them. But realistically, I'd be uploading those files afterwards. Okay, so here we are. We're connected to Smog now. I have no idea what this person has access to. If I type this user, I can see, they don't have anything. They don't have any special attributes. They're part of a group called InfoSec, right? Nothing real special here. For purposes of the demo, I created another script called InfoS, called info, just to sort of shorten up that information, right? So it's just basically pulling information from LU, and so we can see I'm part of this default group. I have no attributes. I can't really do anything. If I try to do like setter ops list, I'm not authorized to do anything special. So this is just a normal user account. What I want to do, now that I have an account on the system, I have my foothold in, I want to increase my foothold, and I want to increase my presence. I want to be able to elevate my privileges to see more things. I want to be able to do more stuff. So at this point, I can't really do much, but I want to see what I have access to. So I'm going to use FTP here. So I'm going to put a file called enum, right, which is a rec script that's available on GitHub. It's freely available. You can contribute to it. You can use it. And I'm going to upload another script that Ayub LaSalle wrote called ELV APF. So I'm going to use these two programs to sort of figure out what's going on in the system quickly and without much trouble. So I'm going to make this so you guys can see. So the first script we uploaded, enum, this is an enumeration script for ZOS. It supports looking at a whole bunch of different items. So you can see I can pass it different arguments. I can pass it all, I can pass it APF, I can pass it cat, job, a whole bunch of different things. So for example, if I pass it the who in here, so infos10.enum, and I pass it the who argument, it's going to show me what started task exists on the system, who else is logged in, right? So obviously my admin account is logged in. I'm logged in for infos10, and funnily enough, because I'm in FTP, it also shows me logged into OMVS. So here's all the jobs that are running, interesting things from there. So you saw earlier, I did setter ops list. I'm not authorized. Like I said earlier, so Jay Taylor wrote some rec scripts that allow you to peer into memory, which will show you the setter ops settings. So if I go enum and I type sec, right? There's two interesting things that are going to come out of this. One, it tells me the security manager, and it tells me the location of the security manager. So it'll tell me, what are you running? Are you running ACF2 top secret RecF? This is running RecF. It tells me the product version, all that stuff. It also tells me the location of the data sets, and it'll tell me my access to those data sets. Now, it's important here to note that I have read access to these data sets, because if I have read access to the data sets, then that means I can copy them off the system, right? I would literally just copy it off with FTP or SCP or some other mechanism, maybe compress it first, copy it off the system, then move it into my test part that you're looking at right now and run database unload on it. So now I know all your security rules. I can search through and do whatever I want, look at what's in there. And then on top of that, I could run John the Ripper against it to try to brute force and offline guess other account passwords. Right, so that's probably the first thing I would do once I saw this. The other thing is I can see, sys1 uads. I might check permissions on that. You can see there's other things like protect always off. This is not a great secure system. It's my demo system. You can see other things in here, and this is all from memory, right? So I didn't have access to setter ops list, but I have access to this. No password rules are defined. What's important for me to know, however, is down here. So KBF AES encryption is active. That's important for me to know because that's going to change the way I try to do the offline brute forcing. Okay, so that's one avenue. So I could do that. I could take the database offline and try to guess passwords for system programmers or security admins of system special. Right? I could try to do that with the RecF database. For the purpose of this demo, that's going to take too long. So instead, we're going to use Ayub's script called elv lv.apf. And you can see here, this script, yep. You can see here, this script will allow me to list APF libraries and their privileges. And then if I pass it an APF authorized library, it'll give me system special. So first we're going to run this command. So copy that, and I'm going to paste it down here. I'm going to run that command. Yep. So put that there. I'm going to run it. And so it's going through in memory and pulling out all the APF authorized libraries, and then it's looking through to see my level of access to those libraries. So it's found 2 APF authorized libraries that I have write access to, so I can upload and do whatever I want. So that's the end of the enumeration phase, right? So I would take all this information back, and I would figure out my next avenue for attack. Do I want to download the RecF database? Do I want to? So I would actually probably do that, compress it in OMVS. I would connect to OMVS. I know I have FTP access, so I would connect in through OMVS, compress it using, gzip or one of the other compression algorithms, and then copy it, do a binary copy in OMVS, compress it down, and then FTP it off, and then do what I want to do with it. Or for this demo, which is even faster to do, I'm just going to escalate my privileges using an APF authorized library. So we'll do that real quickly here. We'll do infos10.elv.apf, and then we'll pass it the sys2.old lib. That was one of the APF authorized libraries. So before this, I'm gonna show you my level of access because it's real quick. So remember, I have no special attributes or nothing. So elv.apf, and then we'll do sys2.old lib. And if I hit enter here, it'll run. That's it. That's literally all it took. And now I can just run this command again. And you can see I have system special, right? Just through one simple command. Now that doesn't mean I have system special now. I could submit jobs that would run as system special, but I don't actually have, like I can't alter a user, right? Like I can't alter a user, I can't, I'm not authorized. But I am system special, so if I log off and log back in, I'd be done, right? Okay, so that's one way to escalate my privileges through TSO and doing all that. I'm going to show you another way now using FTP and SSH. So I'm going to remove the privileges I just gave myself. So real quick here. And that way you can see my privileges have been taken away. So I'm now just a regular user once again. I'm going to log off here. And instead, I'm going to connect through SSH. Let's see here. Into SMOG as InfoS10 through just regular SSH, right? So demo is the password. So you can see I'm on VOS now. You can see, just regular COS. Now, if I try to sue up and get extra privileges, I don't have access to do that. I'm not a special user. I don't have any further access. Same thing if I do, let's see, ex infos10.info. Right, you can see still regular old permissions. If you've been watching any of my talks, if you've seen anything I've talked about, FTP allows you to upload JCL. And we already knew through doing system enumeration or through other means that we have access to an APF authorized library. So I'm going to do something that's going to give me permission and allow me to sudo root. So you can see here there's a file here called secret. So if I try to access that file, I don't have any access to that file. It's been denied to me. So I'm going to log off here. I'm going to go back one folder because that's where the privilege escalation JCL is. So if you look at this file here, it's a bunch of JCL that will put me in system special by editing my ACE and then execute a whole bunch of commands. So let's connect through FTP. Now this time, instead of uploading a file regularly, we're going to do site file equals jez. Okay, so remember, I couldn't sue to root here, but if I upload now, if I upload that JCL, that's it, that's done. And now if I try to, let me see if I can clear the screen here. Make it, nope. If I try to sue up now, I have a different prompt, which is a hash, which in Unix means I have super ID 0. Now I am user ID 0, and I can actually access that secret file. Right, so I can access the file now just by reading the contents of the file. Right, so that's sort of the two techniques I could use to go after the mainframe, and that sort of like start to end on a bunch of my engagements. Let me fast forward through a bunch of these slides here that we've seen. So what did we do, right? So that was real quick for 30 minutes, but basically we scanned SMOG with Nmap, we enumerated applications that exist, and we enumerated user IDs that exist on TSO. So that we could do that for any application. We enumerated and brute forced the TSO FTP accounts connected with X 3270, which is freely available, and escalated our privileges with DLV.apf and that JCL. So that JCL specifically was created with a tool called MSS Venom, which is part of the Metasploit framework. So remember earlier, like a long time ago, I was saying, hey, we created this script and we did privilege escalation. We added like ZOS architecture to Metasploit. That's what we were talking about. I could have done that whole FTP demo within Metasploit itself, but I just felt for this purpose it's easier just to show you normal sort of Unixy type stuff. And that's a lot, right? That's a lot of stuff that I was able to do. And now I'm going to turn over to Peter, and he can tell you and show you, sort of, well, what Phil did. How can I detect that?
Okay, welcome everybody. This is Peter Mills. I'm just getting ready to publish my screen, and right, Janine, if you can just confirm you can see my screen.
Looks good, Peter. We got it.
Okay, so, well, Phil showed us a lot of good things there. So he was posing as a hacker trying to get into a mainframe. Unbeknownst to Phil, we're a savvy mainframe shop, and we were running the CorreLog agent, and we were watching everything he did. So what you're looking at now, this is our visualizations that we've taken the data that we've been monitoring on the ZOS platform. You'll see here smog attack. So what I've done is set up a bunch of dashboards that are taking the feeds from our CorreLog agent, and it's sending them to this visualization tool, what we call the visualizer for ZOS. And I've taken all those feeds from all of the activity that he's been doing, and I put them into different categories and dashboards. So let's just explain what's going on. So here you'll see this is a message. These are the message rates that have come from the smog system. I can drill down, and these are the raw messages. Okay, raw messages in themselves are great when you're doing your forensic analysis, but for the purpose of this demo, I want to see the high level. I want to see what's going on. So this message summary screen here, you can see all of the message types, the SMF message types that we've been monitoring, so we can see all of the activity that Phil's been doing in the last hour. Then over here, our terminal IDs in the last hour, you can see these are all the terminal IDs that Phil's accessed. Now with these visualizations, you can do things like zoom in, and you can say this one here, you can turn those off, and things like that. You can change the time span as well. Okay, so these are the terminal IDs that he was coming in through. Then when you remember when he was enumerating through a bunch of user IDs, looking for a valid user ID, we're tracking all the undefined user ID alerts. So these were those. Okay, and you can click on one of these, drill down, and you can see there's the raw message. So this is a RACF type 80 undefined user ID for the RACF gurus in the audience, event code 1.9, so you can see this was the undefined user ID. Similarly, when he found an ID and he enumerated through a script of passwords and he was using the demo, these are all the failed invalid password events we were getting. So these are 1.1s. So you see we've got a bunch of those. Okay, quite a few of them. Then over here you can see these are a lot of the FTP login failures that he was getting. Over the last 5 days I've been monitoring him, and I see that he's been trying to get in for a while, and these are all the logins that he's been attempting. Then finally, he found one that was valid. So he did this InfoS 10 and the demo. He got a hit. So then he was able to use FTP. And we can go here and we can drill down and see his FTP activity. All right. Then over here, once he had his FTP access, these are the file names that he touched, and he uploaded these files so he could run the APF script. Remember when he looked in and he was looking at the what APF authorized libraries were out there, or which ones he had alter access to? Well, he found one, sys2.oldlib, and I can click down on there, and you can see we got alerts straight away saying that he was accessing this, and you can see add, replace, DSN, APF yes, etc. So you can see exactly what he did and when he did it. So then this little screen here, this is a summary of the ACE privileges that we can see. Now, this is users that have a known privilege. We've seen them before. They've got a known privilege, whether they're authorized or not. These are their standard ones. So you can see, where is it? See this here, privstat known privilege. Okay, so these users, they've been on the system before and they're a known privilege. Now, when he escalated his privilege, we got this alert here, escalated privilege, because he ran that job and it went in and he flipped that bit in the ACE to give him the escalated privilege. So he's running this program, APF priv from sys2 old lib, and you can see privstat E, which is our internal code, privstat escalated privileges. Okay, so what I'm showing you here, these are the raw messages. In a moment, I'll show you what we did about them. This is a summary of all the RACF activity he was doing. This is when he was trying to see if he had access to things. Remember, he tried to give him alt user. He tried to use the alt user command to give him access. So you can see that's where he got the failure. All right. Then down here, these are all the data sets he'd accessed. Once he was in the system and he was able to start nosing around to see what was going on, these were the data sets he accessed. And then if you remember, he ran that job. He wanted to give him super user authority, and then he had the keys to the kingdom. The first thing he did was he gave himself access to the BPX super user facility class, okay? And that was the alert we got for that. And then finally, he was able to, once he had read access to that, he could then give him super user authority, and you can see there he executed the su program to give himself the command through Unix to give him that authority. Okay, so everything Phil did from start to finish, we were watching, and it's all been audited and logged, and you can see in all these great dashboards. So how do we do that? What are we actually looking for? You'll see these are all the raw messages that are coming in. Now, on a busy system, you could have 100 million messages a day or more. So what we do is we create these correlation scripts, correlation rules, these threads that are looking for specific things. Smog superuser, for example, and there's those 3 messages. ACE privilege status, APF alerts, ACE escalated status. If I click there, you can see that. So what these threads are doing, they're watching for specific activity and they're putting them on special queues that we can use. And those queues are what we use from the dashboard. So when I see this dashboard here, escalated status, the rule behind the dashboard says use the selected correlation thread, use a feed from that, okay? So once we've got this information on the dashboard, what do we do with it? We need to alert someone about it. So we've got a bunch of alerts in the system, warning APF, let me zoom in a little bit here. So warning APF authorized library, warning sensitive data set, multiple TSO logons, warning users obtain ACE escalated status, warning super user authority has been assigned. So all of these rules, these things are saying, well, if I see more than one of those in 30 seconds, or if I see 3 of these in 60 seconds, so you can set your own rules. Now, when these fire, when the activity occurs, these will all go red. Of course, they've been and gone. So what happens is when these alerts fire, they create tickets. So these are all the tickets that were created during that session. You can see just 9 minutes ago, 11 minutes ago. You can see we had a warning, user obtained ACE privileges, APF authorized library updated, super user authority, et cetera, et cetera. So we get all these alerts in real time to let us know these things are going on. Now, when these tickets are created, we have actions behind them. We can send an email, we can send a syslog message to QRadar or ArcSight, Splunk, RSA, any other SIM out there. Of course, we have our own SIM, this visualizer for ZOS. We can send SMS text messages. We can send alerts to help desk systems. There's any number of custom actions that you can take to make somebody aware that something is going on. And of course, we have a whole bunch of reporting, so we can do reports, including audit reports, scorecards, PCI DSS activity, things like that. So we've got a whole bunch of reports. Let me just show you one of the emails that we would get. This is an example of an email. Warning, user has obtained ACE escalated status. This should be investigated, etc. And similarly, you would get an SMS text alert as well. Okay. So how do we do this? Just one last slide I want to show you. This is our quick architecture here. The agents are running on each of the LPARs. They take information from SMF user access, so we're getting SMF data in real time. We also access some other control blocks to get additional information. And we take all this, we package it all up and send it to your target SIM. We have multiple redundant connections, so we never lose a message. We have an internal queue. If TCP/IP were to go down or your target SIM were to go down, we'd queue up those messages and then forward them later. Okay, that's pretty much all I had to say in the time we have available. So Janine, I think back to you for questions and answers.
And just a note for our attendees, if we don't get to all of the questions today, please know that someone will respond to your question via email, because I don't think we'll get to them all. Okay, let's get started. First question, is there a mainframe penetrating community somewhere online, like a forum?
Phil, do you think you can answer that one?
Yeah, not really. Twitter is kind of where we gather. Twitter and I guess GitHub is kind of where we gather. But there's not like a specific. We tried to set up a mailing list, but it's basically just everyone signed up so they could hear what Chad and I had to say, and so we don't really use it. But you know, Twitter, that's pretty much the current community. It's so small anyway, so.
Okay. Well, I kind of just have to pick and choose these, but I'm going to take this one that's kind of like devil's advocate here. Most security systems have the passwords encrypted, so even if you have a password, all that would get you is the ability to log in. You still wouldn't have access to anything outside of what the user is allowed to do. Just comment on that?
Yeah. So there's a couple of things here. I didn't need to know what the encrypted value was, right? So I think there's some misconceptions about like, oh, I'm using password hashes and therefore my password is safe. It's only safe so long as you lock those password hashes down and you salt them appropriately. If not, you can actually look online. You can go to an MD5 cracker that'll crack MD5 hashes, right? And it's just online. Chad gave a great talk at Share last year about how long it would take to crack a DES password. If you're not using KDF AES, if you're just using the older DES one-way hashing algorithm that IBM implemented, John the Ripper is able to crack something like one password in 2 days on a specific rig built for cracking password hashes, right? So that's sort of one way to do it. The other thing is I only needed one account on the system, and in fact, in my experience, I usually am able to get 3 or 4 accounts using a dumb password. So I'm able to get my foothold in the door, and then from there, see what else I can do, right? It's whatever the user's allowed to do. So if the user's allowed to access an APF authorized library, or if the user has surrogate access to something, or if the user has something else, there's all kinds of areas that I can explore that may have been overlooked by your auditors or your compliance folks or anyone doing that kind of work, right? These systems are large and have grown organically over decades. So there's multiple avenues for attack.
Okay. How about a couple comments about, what's it, the APF library? Trying to get.
How about question 39 there?
Yeah, okay. How does CorreLog know that the data set being accessed is APF authorized? Thanks, George.
That's because we maintain an internal list of what we know. On startup, we've already accessed the list. We know what data sets are APF authorized, and then we're monitoring system activity throughout the life of an IPL session or while the agent's running. So if someone were to use a set prog to dynamically APF authorize something, we would trap that and add that to our list. So we're aware of all APF authorized data sets on the system.
Okay, Peter, how about this one then? To what extent does CorreLog rely on proper RACF auditing options to be set up to see events? Does that make sense?
Well, we
Peter?
see all we see all RACF events. So everything that goes through the SMF type 80 records, then we will see all of them. So you also if you don't have a RACF profile set up to see particular data sets, then you won't necessarily get a RACF alert. So we're monitoring all accesses to all data sets so that we see activity beyond what you see through say, a RACF alert. So you can build lists of sensitive data sets outside of RACF profiles. We have lists within the system. We have matches and filters that we can use. So if you have a list of sensitive data sets that are not necessarily in RACF profiles, any hit on those. So we're looking at file opens and closes. We're looking at type 42s for PDS member activity. We're looking at all of that. And so we're constantly matching and correlating data from a large number of different message sources to decide what we should alert on.
Okay, and for those of you that can't stay with us, because I'd like to take a couple more questions due to our delay with the technical difficulties, I just want to let those of you who do have to go at the top of the hour know that we will be sending out a follow-up email with a link to a recording of today's event. And so with that, I'd like to take a couple more questions. This one asks, for you, Phil, how was he able to update BPXAs and change his own level of authority? Isn't anything concerning changes to SU access restricted by RACF?
Yeah, well, so yes. So you saw earlier in the demo I tried to alter a user and I didn't have permission to alter the user ID, right? So I couldn't alter my access as well. And then you saw during the second part of the demo, I was able to, I tried to type the SU, which, bpx.superuser in the facility class is what controls access to that. And so if I tried to type SU, it wouldn't work. And so what I did was I had JCL prepared by Metasploit that changes my ACEE using an APF authorized library. And the reason I use that demo specifically is because in my experience, developers and some dev LPAR, or there'll be some LPAR somewhere where someone has access to APF authorized library who's not a system programmer. And so from there, it's just a matter of putting in my own library, my own module in that library, executing it, which changes my ACEE, gives me system special, and then using the permit command, giving myself permit on bpx.superuser within the facility class. Right, so that's how I was able to escalate my privileges in OMVS.
Okay, next question. How is that possible to keep trying to crack a password when you are locked out entirely after a fixed number of missed attempts?
Okay, so there's a difference between online and offline password cracking, right? So you saw in my demos, I gave examples of online password cracking, which is brute forcing. I'm trying to guess passwords for users. Those will definitely lock out after 5 attempts. In the real world, 3, 5 attempts, those accounts are going to get logged out. Everyone knows that. Everyone knows that that's the system. NIST recommends it, so no one tries 5 passwords anymore, right? They would just lock out every account. What we do is we try 1 password across every single account. So that's online password cracking, which is not as fun as the other version, which is offline password cracking. Offline password cracking, as you saw during the demo, I had read access to the RACF database. What I would do is I would copy that to my local system that I control, and using a tool called John the Ripper, and you can see that if you look at my other talks, I talk about John the Ripper and how fast it is at cracking password hashes. What you do is you download the RACF database to a Unix or a MacBook that I have. I run a tool called John that rips out all the password hashes in the RACF database and the user ID, and then tries to crack them using easily guessable passwords, right? Or you can just brute force, right? The space is very short. It's only 8 characters. So it doesn't take very long to crack an entire database. If you look at the Logica breach that happened in Sweden, they had 104,000 accounts, and using John the Ripper, the person was able to get the passwords for 102,000 accounts. So it was just a matter of time for cracking them. And that's offline. So the offline, I control the system that's doing the cracking. I'm not going to put on limitations on lockout thresholds or anything.
Okay, last question is for Peter. Do you have workflows for compliance standards in my vertical? This person says, I work for a government contractor, or I work as a government contractor, not sure which. So FSMA is important.
Yes, absolutely. We have workflows and scorecards and things for all the common standards. And what we do during implementation, we will work with you to build those workflows, build those scorecards, so you can track exactly what you need and produce evidence for the auditors that you're in compliance.
So, Pierre, do you know off the top of your head any others that is just like a standard, like besides FSMA?
HIPAA, IRS Pub 1075, NIST, GLBA, FIPS, FERPA, ISO 27001, etc., PCI DSS, a whole bunch of them.
Perfect. Okay. I didn't even know the list would be that long. So, unfortunately, we've actually gone over our time for today, but it was so interesting. I want to thank everyone for attending today's webinar. I especially want to thank Phil and Peter for sharing their expertise with us, and to all of you for joining and for being patient through our little technical glitch there. We appreciate you. Later this week, as I mentioned, we'll be sending out the link to the recording of today's webinar in a follow-up email, so do watch for that. That concludes our webinar. Thanks again, and have a great day.